Okay, this is Dalton's law of partial pressure. The first thing that we're going to do is define and write the formula. You should have at this point done all of your pressure conversions and your Celsius and Kelvin conversions. So make sure you check those answers before you move on, because there'll be some pressure conversions here. So to define and write the formula, this is Dalton's law. States that the total pressure which that's what this stands for, pressure total. We'll always put these subscripted helpers to help you know what the P stands for. So Dalton's law states that the total pressure is the sum of all of the partial pressures. Which in this case I'm going to write P1 plus P2 plus P3. It could be anything. It could be PO2, PN2, PHE, whatever these pressures are, and whatever the gases are. So Dalton's law states that the total pressure, P total, is the sum of all the partial pressures, in this case P1, P2, P3. We can even put a ... because there could be 4 or 5 of a gas mixture. And so kind of referring to things like our air is a gas mixture, oxygen, carbon dioxide, nitrogen, argon, whatever's in our air, and we would add those all up and it would equal up the total pressure of our air. So let's do a problem or two together. Number 1 says, I have a flask with 3 gases inside. So we would have a P1, a P2, and a P3. In this case, the oxygen has a partial pressure of 0.23 atmosphere, while the nitrogen exerts a pressure of 0.64 atmospheres, and the helium has a pressure of 0.090 atmospheres of pressure. What is the total pressure in the flask? So our formula would be P, and we'll use a capital T for total so we don't have to write the word total out every time, equals, and instead of using P1, we'll actually write the formula for whatever it is. So we'll equal the pressure of oxygen, because that was our first one, plus the pressure of nitrogen, because that was the second one, plus the pressure of helium, because that was the third one. And these are really, really easy. All you're going to do is put in the numbers and then simply just add them together. So 0.23 atmospheres, don't forget your units, plus 0.64 atmospheres, plus 0.090 atmospheres. And we'll just go through and add all those together in your calculator. If you want to pause to make sure that you can get yours the same as mine, you can do that. So putting those all in the calculator would be P total equals 0.96 atmospheres. And as usual, make sure you have your number, make sure you have your unit, and you can box your final answer like that. So all we had to do was we had to go through and identify every single one of the partial pressures that they gave us, here, here, and here, and then we just added them together using our calculator. Okay, on the second one, I'll do one more, and then the third one you'll have to do on your own, and there'll probably be some conversions in this one. So on the second one, a barometer reads 738 millimeters of mercury. If there are 2 gases exerting pressure on the barometer, and one gas we know has a partial pressure of, and so here's my first piece, 0.060 atmospheres. Now this is, whenever the barometer reads, that's going to be our P total. So I like to just identify them inside of the problem there. That's going to be our pressure total. And this is going to be one of our partial pressures. The problem with this that you should notice is that the units here, the millimeters of mercury and the atmospheres, are 2 separate units. We can't deal with 2 separate units in the same problem. So we're going to have to convert this into millimeters of mercury. We could do it the other way. It really doesn't matter. Just find one and convert it. Now we should have already done that. If you watched the videos on how to convert, you should have already done that in questions 11 through 17. And so we'll kind of do this to the side here. We'll just say this needs to be converted to millimeters of mercury. And so to do that, we know that 1 atmosphere equals 760 millimeters of mercury. So we write our given. Just going to do a conversion that we've been doing all year. 1 atmosphere on bottom, 760 millimeters of mercury on top. In other words, I'm multiplying by millimeters of mercury, because if 1 atmosphere is 760, you multiply this by 760 to find how many millimeters of mercury you have. So you can do that in your calculator. You should get something like this, about 456 millimeters of mercury. And then that's what you'll actually use in the problem. So this will be your partial pressure. One of your partial pressures, we'll call it P1. Okay, so our formula basically here, since it says how many millimeters of mercury is the other gas, so we're assuming there's 2. This would be 1, the other would be 2. So other gas would be P2. So P total equals P1 plus P2. We have our total, so this one's a little bit different in that this time we actually have the total and we have one of the partial pressures. We don't have P2. This would be our other. So to do this, simple algebra, we'll take 738 millimeters of mercury, subtract that, and that will give us this. So you can pause here if you wanted to try to do that in your calculator, see if you get the same thing that I do. Kind of make sure you're understanding how everything got put into those places. P2 equals 282 millimeters of mercury. And that's as tough as those get, so try to do number 3 on your own, and then you'll have to check the answer key that will eventually be posted to make sure you got it right. Don't forget on this one that all of these will need to be in the same unit of pressure because they're all in different ones.